Hello everyone, welcome to Compiler Design video series. In our previous video, we have already discussed about phases of compiler, the grouping of phases, analysis synthesis phase of compiler, front end back end of compiler, path structure of compiler. In our this video, we have discussed about unit 2, which is lexical analyzer, and topics to be covered in these videos are introduction to lexical analyzer or role of the lexical analyzer, input buffering techniques, specification of tokens. What is the role of lexical analyzer? The first phase of compiler is lexical analyzer. Its main task to read the input characters and produce as output a sequence of tokens that the parser uses for syntax analysis. The stream of token is sent to the parser for syntax analysis. It is common for lexical analyzer to interact with the symbol table as well. When any lexeme is generated, then it is stored in symbol table. So how it works? Here we give source program. Source program gives to the lexical analyzer. Lexical analyzer do the scanning or lexical analysis. Then after it generates the token. At that time any lexeme, token or identifiers which is stored in symbol table. Lexical analyzer generates token and give it to the next phase of compiler, which is parser or syntax analyzer. If it is a valid token, then parser send the get next token to the lexical analyzer. Then after lexical analyzer again send token to the parser. So that source program is converted into stream of tokens which is passed to the syntax analyzer or parser which generate the syntax tree. So lexical analysis versus parsing. There are several reasons for separating the analysis phase of compiling into lexical analysis and parsing. First is simplicity of design is the most important consideration, because the separation of lexical and syntactic analysis often allows us to simplify one or other of these phases. For example, a parser which is deal to comments or any white spaces. Whenever you passed any source program, in that source program, if any white spaces or any comments will come, then it is removed by lexical analyzer. Second is compiler efficiency is improved. A separate lexical analyzer allows us to apply specialized techniques that serve only the lexical task, not the job of parsing. So specialized buffering techniques for reading characters speed up the compiler process. Any white spaces or any comments which will be removed by lexical analyzer, so it speed ups the process. And third one is compiler portability is enhanced. Any input device specific peculiarities can be restricted to the lexical analyzer, so we can easily portable it. Next is token, pattern and lexemes. These all things we already discussed in our previous video also. Then first, what is token? So token is a sequence of character having a collective meaning. Typical tokens are identifiers, keywords, operators, special symbols, etc. The token name is an abstract symbol representing a kind of lexical unit. In token name, it considers two values. First one is attribute name and second one is attribute value. The token names are the input symbols that the parser processes. Then what is pattern? It is the set of rules called associated with a token. In case of keyword as a token, the pattern is just the sequence of character that form the keyword. For any identifiers, it is more complex structure to find the pattern. Then what is lexeme? The sequence of character in a source program matched with a pattern for a token is called lexeme, and it is identified by the lexical analyzer as an instance of that token. So here the examples of tokens. If you have any constant, then lexeme is also a constant. If you used any keyword like if, else, then lexeme is also same. If. Simple description, which is character I and F. Any comparison operator or relational operator, which is less than or equal to, not equal to, greater than equal to, or greater than. If any identifiers are used, identifiers like any variables, pi, count, and I. So variable name is a start with letter followed by letters or any digit. You can declare A1, but you can't declare 1A, because the rules of identifier, which is start by letter, not start with digit. Underscore is a valid identifier. Then after any number, you can use any integer, float, or any exponential number, which is numeric constant. Then literal is nothing but a group of characters. In lexemes, it is identified by double quote sign. You can write any string in double inverted comma. In this lexeme, I write my name Bhumi Bangoria. Description is any character between double inverted comma. So next is example like C is equal to A plus B into 8. Then how this source program is identified by the lexical analyzer? It scans the source program from left to right. First is C, which is one type of identifier. Then after equal to assignment symbol, A is a identifier plus the addition symbol, then B identifier, star multiplication symbol, then 8 any number. You can write any example for source program. Next is input buffering techniques, or why we used input buffering techniques for lexical analyzer. So we already know that lexical analyzer scans the input one by one character by one character. Then it is a time consuming process in case of large amount. So there are mainly two techniques are used for input buffering. Input buffering is used for speed up the lexical analysis. So there are mainly two techniques for input buffering. First is buffer pairs and second is sentinel. So in buffer pair, according to its name, it used buffer in pair. There are two buffer which has equal size. The lexical analysis scans the input string from left to right and one character at a time. In case of large source program, it takes more amount of time for processing. So specialized buffering techniques have been developed to reduce the amount of overhead required to process a single input character. An important scheme involves two buffers that are alternatively reloaded as shown in figure. Here you show two buffers. First is n size and second is also a n size. So this buffer is divided into equal size. In input buffering techniques, buffer pair, each buffer is of the same size and n is usually the number of characters on one block. If you used 4096 bytes, then it used 2 raised to 12 characters in a single buffer. Using one system read command, we can read n characters into a buffer. If fewer than n characters remain in the input file, then a special character represented by end of file, which is known as EOF, like shown in figure, end of file. If you have less than n size input, then at the end of input string this character is used. Two pointers to the input are maintained, which is lexim begin pointer and forward pointer. Lexim beginning marks the beginning of the current lexim whose extent we are attempting to determine. Forward pointer scans ahead until a pattern match is found. This forward pointer is incremented until your source code is found. It finds the pattern match. If forward pointer is at the end of first buffer half, then second buffer half is filled with an input character. If forward pointer is at the end of second buffer half, then first buffer is filled with an input character, like shown in figure. If first buffer half is completed, then it loads the second buffer with n input characters. Then Lexim beginning pointer is point to the starting of the second half, and forward pointer is incremented until it finds the match pattern. So code to advance of forward pointer is, if forward pointer is at the end of first half, then begin to reload the second half. If your forward pointer is reached at the first half, and then it loads the second half, and forward equal to forward plus 1 and end. If not at the first half end, then forward at the end of second half, then begin reload first half. If your forward pointer is at the end of second half, then it's reload the first half and move forward pointer to the beginning of the first half. It means whenever your forward pointer is at the end of any buffer, then load the second buffer. If it is the end of first half, then load the second half. If it is at the end of second half, then load the first half. Otherwise, forward pointer is increment by 1. So forward equal to forward plus 1. This process is continuous until it matches the pattern. Second one is sentinel. Sentinel is nothing but a special character which is used for end of file. If we use the scheme of buffer fair, we must check each time we advance forward pointer that we have not moved off one of the buffers. If we do, then we must reload the other buffer. In case of buffer pair, each and every time we have to check forward pointer is the end of any half. If yes, then we have to load the second buffer. So we don't know it is the end of first buffer or end of second buffer. At the end time, we show that now there is no any space, no any buffer to store the character, so we have to reload the second character. To overcome these issues, sentinel is used. Thus, for each character read, we make two tests, one for the end of buffer and one to determine what character is read. So in the case of sentinel, at the end of buffer, special character which is known as EOF is placed. We can combine the buffer and test with the test for the current character. If we extend each buffer to hold a sentinel character at the end, the sentinel is a special character that cannot be part of the source program, and a natural choice is the character end of file. So in the sentinel case, there are two buffers. At the end of each buffer, we have put end of file, which is known as sentinel. So whenever forward pointer is at end of file, then we know that this is the end of first buffer. So now we have to load the second buffer. Before the end of file, if your input is over, then also put end of file. Note that EOF retains its use as a marker for the end of the entire input. Any end of file that appears other than at the end of buffer means that the input is at an end. Here you can see that end of file is rather than end of half. So it indicates the input is end now. So how sentinel is works? First, forward equal to forward plus 1, increment the forward pointer. If forward pointer is equal to end of file, then begin. If forward at the end of first half, then begin reload the second half. Here first increment forward pointer. If forward pointer is at end of file, it means if your forward pointer is at this place, then you have to reload second buffer and forward equal to forward plus 1. Else if forward at the end of second half, then begin to reload the first half and forward pointer moves to the beginning of the first half. If your forward pointer is at this place, then you have to reload the first half and your forward pointer is moved to this place. It means beginning of the first half. So these input buffering techniques are used to speed up the lexical analysis. Next is specification of tokens. Regular expressions are an important notation for specifying any lexeme or patterns. So first, what is regular expression? So the language accepted by finite automata can be easily described by simple expression called regular expression. It is the most effective way to represent any language. Regular expressions are used to match character combinations in strings. String searching algorithm used this pattern to find the operations on a string. So what is regular language? The language defined by regular grammar is known as regular language. Then what is regular grammar? The grammar defined by regular expression is known as regular grammar. So there are three specifications of tokens. First strings, second language, and third is regular expression. Strings and language. Then what is strings? What is alphabet? An alphabet or character class is a finite set of symbols. All of you know very well A to Z, capital A to Z and small a to Z is a class of character or alphabets. Then a string over an alphabet is a finite sequence of symbols drawn from the alphabet. You can write any string, then you used alphabets from A to Z. A language is any countable set of strings over some fixed alphabets. In language theory, the terms sentence and word are often used as synonyms for string. String is nothing but a group of characters, group of meaningful characters, or any sentence or any word. The length of string S, usually written in mod S, is the number of occurrences of symbols in string S. For example, banana is a string of length 6. Here total 6 characters are used, B, A, N, A, N, A. So string of length is 6. The empty string is denoted by epsilon, is the string of length 0. Which type of operations are performed on a string? So some prefix, suffix, proper prefix, this type of operations are performed on a string. Here we used one example. According to that example, we can identify which type of operations are performed on string. Prefix of string S is any string obtained by removing 0 or more symbols from the end of string S. For example, BAN is a prefix of banana. So starting symbol from 0 or more symbols from leading string. Here BAN is a prefix of banana. B is also a prefix of banana. BA is also a prefix of banana. BANA is also a prefix of banana. Suffix of string S is any string obtained by removing 0 or more symbols. For example, NA is a suffix of banana. ANA is also a suffix of banana. Substring of S is obtained by deleting any prefix and any suffix from S. Substring, it means any string given from your string. So NAN is a substring of banana. ANA is also a substring of banana. Proper prefix, suffix and substrings of a string S are those prefix, suffix and substrings respectively of string S that are not epsilon or not equal to S itself. It means it's not same as given string or an empty string. Subsequence of S is any string formed by deleting 0 or more not necessarily consecutive positions of S. For example, BAAN is a subsequence of banana. Here we used BAAN, which is a subsequence of banana. Which operations are performed on languages? The following are the operations that can be applied to any languages, which is union, concatenation, clean closure and positive closure. So here we see that with example. Let we take L is equal to 0, 1 and S is equal to ABC. Using this example, we can use union, concatenation, clean closure and positive closure. So union, you can use this both sets 0, 1, A, B, C. So union of L and S, which is represented like this, and answer of L union S is equal to 0, 1, A, B, C. 0, 1, A, B, C. Concatenation, the set of 1 with is concatenated by another set. L concatenate S, 0 A 1 A, 0 B 1 B, 0 C 1 C. Each and every element of first set is concatenate with each and every element of second set. Next is clean closure. What is clean closure? It means 0 or more occurrences of given set. 0 occurrences, it means empty. L, which is denoted by L star. L is a given language. Then L star. So what are the values in this set? It's a epsilon. Then after, if star equal to 1, then it means either 0 or 1. So 0, 1. If it is 2, then combination of this 2, 0 and 1. So which is 0, 0. Next is 0, 1, 1, 0, 1, 1, etc. Next is positive closure. Positive closure means one or more occurrences of a given set. In this closure, at least single elements are come in the set. So for example, L plus, positive closure is indicated by plus sign. So L plus either 0 or 1. If it is 2, L power 2, then 0, 0, 0, 1, 1, 0, 1, 1, etc. Next is regular expression. Each regular expression R denotes the language L of R. Here are some rules that define the regular expression over some alphabet sigma, which is used for input symbol, and the languages that those expression denote. The epsilon is a regular expression. Then language of epsilon is empty string, that is the language whose sole member is the empty string. If A is a symbol in input, then A is a regular expression and denoted by L of A is equal to A, that is the language with one string of length 1 and input A in its one position. Suppose there are two regular expressions R and S denoting the languages L of R and L of S, then R or S is a regular expression denoting the language L of R union L of S. In language you can use union size. In regular expression you can use OR sign. This is denoted by OR or plus sign. R S is a regular expression denoting the language LR LS concatenation. R star is a regular expression denoting language L of R star. R is a regular language then denoting L of R. The unary operator star has highest precedence and is left associative. Concatenation has second highest precedence and is left associative. OR has lowest precedence and is left associative. Today we discuss about introduction of lexical analyzer or role of lexical analyzer, input buffering techniques, specification of tokens. So which type of questions to be asked in GTU exam? First, what is input buffering? Explain its techniques. Here It indicates marks. It is not fixed. It may vary. Which technique is used for speeding up the lexical analyzer? Here you have to write input buffering techniques. Explain role of lexical analyzer. Explain specification of token. Thank you.